So this is 6.3, the arc length homework. There were 4 problems, they're story problems. So number 1 says, what is the speed of an Earth satellite in kilometers per minute, traveling in a circular orbit 1,000 kilometers above the Earth's surface, if it completes one orbit every 90 minutes, and were to use 6,400 kilometers for the Earth's radius? And we need to give our answer in kilometers per minute. So this one, it's kind of helpful to draw a picture. So we've got the Earth. And we know that because the story problem told us that the radius is 6,400. But we want to know the speed of an Earth satellite that's traveling in a circular path 1,000 kilometers above the Earth's surface. So we have a satellite up here that's an additional 1,000 kilometers above the Earth. So we now have our R is the 6,400 plus the 1,000, or 7,400 is now our R. Now again, we know that 1 revolution equals 2 pi, because any full revolution of a circle is 2 pi. And we know that we complete that 1 revolution in 90 minutes. So we have 1 revolution every 90 minutes. So we have our R, and we're doing 1 revolution. So we have our theta. So we need to find our L. So L equals R theta. So we have 7,400 times 2 pi. So we're going to get 14,800 pi. And you can multiply that pi through if you want. And then, so this is in kilometers. So that's the distance that it travels in 1 revolution. The satellite travels in 1 revolution. But we need a speed. So we're told that it completes this 1 revolution, or this 1 orbit, in 90 minutes. And it tells us up here that our speed should be in kilometers per minute. So we're going to take the kilometers that we just found, the 14,800 pi kilometers, and we're going to divide by the 90 minutes that it took to complete that 1 orbit. So now we have kilometers over minutes, so we have our speed. And when we divide this out, we get 516.6 kilometers a minute. Number 2 is very similar to our first example in the homework, or in the notes. It says the tip of the minute hand on a watch travels 180 centimeters in 36 hours. What is the length of the minute hand in centimeters? So we have that the tip of the minute hand of a watch travels 180 centimeters in 36 hours. So we know how long or how far it's traveled. So that's our L. 180 centimeters gives us our L value. And this is in 36 hours. And we're looking for the length of our minute hand. So we're looking for R. R is what we're looking for. So if we think about this again, we know that we've traveled, or that it's taken 36 hours to travel this far. And if we want to get our hours into revolutions, we know again that for every 1 hour, we have 1 revolution, because this time we're looking at the minute hand. So for every hour, or 60 minutes, we complete a revolution of the minute hand. So we get that we have 36 revolutions. So now this revolutions again, we have 36 revolutions now, but we want to get that into our radians. So 1 revolution again is 2 pi. So our revolutions cancel out, and now we're in our radians. So you're going to get 72 pi is the angle that we've traveled, or the rotation that we've traveled around the watch. So now we have an L and we have a theta, and we're looking for R. So L equals our theta again. So our L was 180 centimeters, and that equals R times the 72 pi. So we're going to divide 180 by 72 pi, and we get that R is approximately 0.795. So the minute hand on our watch is approximately 0.795 centimeters, because our 180 was in centimeters. Number 3, we have a Ferris wheel makes 1 revolution in 15 seconds. The radius of the wheel is 6 meters. What is the speed in kilometers per hour of a person riding on the Ferris wheel? So again, we know that we have 1 revolution equals 2 pi. So we know our theta. It tells us right here that the radius of the wheel is 6 meters. So we have our R. We have to find our L so that we can find the speed. So L equals our theta, which equals 6 times the 2 pi. So you get 12 pi as your length. And now we need a speed, and our speed needs to be in kilometers per hour. Our length, as it stands right now, is in meters, because our radius was in meters. So we're going to take 12 pi meters, and we know that it made this 1 revolution in 15 seconds. So we're going to put that over 15 seconds. Now we just need to convert our meters to kilometers and our seconds to hours. So to get the meters, there's 1,000 meters in 1 kilometer. So our meters cancel, and now we're left with kilometers. And we have seconds. So there are 60 seconds in 1 minute. But we have to go to hours. So for every 60 minutes, there's 1 hour. So our seconds cancel, and then the minutes cancel, and we're left with kilometers over hours. So now we simply multiply through 12 times 60 times 60, divided by 15 times 1,000. And you should get 9.0477, and this is kilometers an hour. So your speed is 9.0477 kilometers per hour. And number 4. Number 4 says the Earth spins on its axis and makes 1 revolution every 24 hours. What is the speed in kilometers per hour of a point on the equator? And again, we're to use 6,400 kilometers for the Earth's radius. So again, we know that 1 revolution is 2 pi. So we have our theta again. We have the Earth's radius, so we have our r. So again, using L equals our theta, we're looking for our L. So we put 6,400 in for our r, times 2 pi is our theta. And you get 12,800 pi for a length. This is in kilometers, because our radius was in kilometers. And we need to find the speed in kilometers per hour. So we know that it made this 1 revolution, so it traveled this distance in 24 hours. So we're going to take our 12,800 pi kilometers and divide by the 24 hours that it took to complete that distance. And you'll get approximately 1,675.5 kilometers per hour. So this, for this revolution, the Earth spins approximately at a speed of 1,675.5 kilometers an hour. And we're done.